Have you ever wondered how steep a mountain is, or how fast a cheetah runs? That's where slope comes in. Slope is a measure of how steep a line is. It tells us how much one thing changes compared to another. In math, we use slope to understand linear relationships, where things change at a constant rate. Imagine you're climbing a hill. The steeper the hill, the harder you have to work. That's because the slope is greater. A flat road has zero slope. It doesn't go up or down. A downhill slope? That's a negative slope. You're going down instead of up. Slope is important because it helps us visualize and analyze relationships between things. We can use it to make predictions and solve problems in all areas of life. From building bridges to designing airplanes, slope is a fundamental concept in math and science. So how do we actually calculate slope? It's easier than you might think. We use a simple formula: rise over run. Rise refers to the vertical change, how much something goes up or down. Run refers to the horizontal change, how much something moves sideways. To calculate slope, we divide the rise by the run. For example, imagine a ramp that rises 2 feet for every 10 feet of horizontal distance. The rise is 2, and the run is 10. So the slope is 2/10, which simplifies to 1/5 or 0.2. The slope formula can be written as slope m equals y2 minus y1 divided by x2 minus x1. This formula works for any 2 points on a line. Just plug in the coordinates of the points and solve for the slope. Parallel lines are like two roads that never meet. They run alongside each other, always the same distance apart. In math, parallel lines have a special property: they have the same slope. Think about it. If two lines have the same steepness, they'll never intersect, no matter how far they extend. That's because they're changing at the same rate. It's like two runners running at the same speed. They'll stay side by side. We can use this property to identify parallel lines and solve geometric problems. For example, if we know the slope of one line, we can easily determine if another line is parallel to it by calculating its slope. Section 4. Perpendicular lines, a right-angle dance. Perpendicular lines are like two streets that intersect at a perfect right angle. They form a cross, with one line going straight up and down and the other going straight across. In math, perpendicular lines also have a special relationship with their slopes. Their slopes are negative reciprocals of each other. What does that mean? It means if one line has a slope of 2, the perpendicular line will have a slope of -1/2. The slopes are flipped and have opposite signs. This ensures that the lines intersect at a 90-degree angle. Understanding perpendicular lines is important in many areas of math and engineering. We use it to construct geometric shapes, design buildings, and even program robots. Section 5. Slope in the real world, from ramps to roller coasters. Slope isn't just a theoretical concept, it's all around us. We encounter slope every day, from the ramps we walk on to the roofs of our houses. Engineers use slope to design roads, bridges, and roller coasters. Architects use it to create aesthetically pleasing and structurally sound buildings. In physics, slope is essential for understanding motion and forces. The slope of a distance-time graph gives us the speed of an object. The slope of a velocity-time graph tells us the acceleration. Slope helps us analyze and predict how things move and interact. Even in the business world, slope plays a role. Financial analysts use slope to analyze trends in stock prices and make investment decisions. Marketers use it to understand consumer behavior and optimize pricing strategies. Section 6. Wrapping it up. Slope's significance. Slope is a fundamental concept in mathematics and a cornerstone of our understanding of the world around us. It allows us to quantify steepness, analyze linear relationships, and make predictions about change. From calculating the incline of a ramp to designing skyscrapers, slope has countless applications in science, engineering, and everyday life. By understanding slope, we gain a deeper appreciation for the patterns and relationships that govern our universe. So the next time you see a hill, a graph, or even a roller coaster, remember the power of slope. It's a simple concept with profound implications.